Is 3 less than 50? Obviously. And then it's going to print hello world. And it's going to continue that process. Take a guess how many times? 50 in total. Because eventually, and we won't bore ourselves with the whole story, eventually I is going to equal 50 because of a whole bunch of pluses. And at that point in the story, the computer's going to ask the question, is 50 less than 50? No, obviously not. And at that point, the code stops executing. And whatever is below it in your program, like lower in your file, that's what's going to happen next, even though there's nothing pictured there. So again, cryptic, but it follows this pattern. And once you sort of get comfortable with that pattern, you're going to be able to bang this out on a keyboard and just know what it's supposed to do without even having to think about it so methodically. Now, the other day, this was perhaps the biggest set of puzzle pieces we played with in person, even though it's probably just a small piece of some of your own Scratch projects now. But it actually maps pretty nicely to C code. It's not colorful in the same way, but you'll see that the other day when we asked, is x less than y? In code, it actually looks pretty identical. In fact, it might be a little simpler to look at. We just have some parentheses. We have the less than sign. And of course, x and y, which in this context are assumed to be variables, like x and y in algebra. Where do they come from? I have no idea. In this context, we're just assuming this is part of a bigger program. So if x is less than y, print out x is less than y. Else, if x is greater than y, print out x is greater than y. Else, print x is equal to y. And so just like these yellow puzzle pieces kind of are embracing the purple puzzle pieces, similarly do you have these curly braces, which maybe you have never actually had occasion to use on your keyboard, but odds are they're there, probably around your Enter key on a US keyboard. These are like sort of wrapping the lines of code that you want to actually execute. Now, there's a curiosity I haven't called out just yet, and we'll come back to this. This weird \n, we'll see why that is there in just a moment. So let me pause for just a moment, because that was already a mouthful. Any questions on functions or on loops or on conditions as we begin to translate them from Scratch to C? Anything at all? Yeah? Good question. Why are there 2 plus signs and not just one? If you have just one plus sign, and we'll actually see this in a bit in an example, that literally means add one number on the left to one number on the right. So in this case, it's just because is kind of the trite answer. It's because if we want to have this special operation where there is no number on the right, you're just adding 1 to the number on the left. Humans years ago just decided plus plus is pretty succinct, and it's not used for other purposes yet. So that's all. Yeah? Yeah, right there. Correct. I wouldn't start thinking about it as having a loop inside of it, because we'll eventually see that you can literally put another for loop, as it's called, with the keyword for, inside of another by indenting it inside. So think of, when you're looking at a for loop, like the one we just saw a moment ago, think of the loop as really being all 4 of these lines. And like something is just kind of happening cyclically around the whole body of that code, so to speak. Other questions? Yeah? Why do we use int for the main method? Let me take the fifth on that for just a moment. What you're alluding to, just to be clear, is this example here, whereby in our most canonical, sort of simplest, relatively speaking, but program that does the least amount of work possible, we also mentioned int here. We also mentioned this curiosity here, void. Let me just defer that answer for a little bit until we have the vocabulary with which to answer that. All right, so we've looked then at functions, at loops, and conditions, but there were a couple of other puzzle pieces that we looked at before. But for now, we're going to take those as our sole translations, just to kind of give you a taste of the fact that even though the syntax is different, you might have never have typed these characters on your keyboard before, the ideas today are exactly the same as last time. But of course, even as we humans begin to write code, code is just characters on the screen like this. The problem is, per our first lecture, computers don't speak pseudocode. They don't speak English per se, and they don't even speak code per se. What's the only language we claimed computers understand? Yeah, ones and zeros, or binary. At the end of the day, they only understand zeros and ones, and they can do a whole lot with those zeros and ones. But somehow, if I, the human, am going to type stuff like this on my screen, before my Mac or PC can understand it, unfortunately, I'm going to have to literally convert it to zeros and ones. And back in the day, back even on this campus years ago, you might have heard of punch cards growing up or in a history book or the like, which effectively captures symbologies like this. People did, way back in the day, program in binary, at least early on. Then they invented other languages that were a little nicer to use, and then they invented other languages that were yet nicer to use. But at the end of the day, our computers, Intel inside, still just understands this. But thankfully, we, the humans, don't need to worry about why those zeros and ones actually mean, hey, computer, print hello world on the screen, because of the following. We, henceforth, are going to write source code. And that's technically what you did with Scratch. Even though you dragged and dropped puzzle pieces, you were writing source code, sort of human-like syntax that's just more digestible for us. But we ultimately need to convert source code to what's called machine code, zeros and ones, that Intel CPUs or other CPUs actually understand. Thankfully, humans who've come before us have invented software, generally called compilers, whose sole purpose in life is to translate source code, like we've been seeing on the screen, into machine code, zeros and ones. And in fact, this is a whole research area in computer science as to how to do this well, how to do it quickly, especially for really big programs. This is a tool that we'll use as a tool in CS50 so as to not worry about how those translations actually happen. And to do that, we're generally going to use all the same environment, something called CS50 IDE, where IDE stands for Integrated Development Environment, which is just a fancy way of saying a computing environment that's identical for all of us. Because frankly, especially when getting into programming, one of the easy frustrations can be following a whole bunch of directions on one's Mac or on one's PC just to get your environment to be identical to someone next to you. But invariably, some of us have different browser versions. Some of us have different versions of Mac OS or Windows. And it's just a massive headache trying to get everyone onto the same page. And so increasingly in industry, it's very common, even within companies, for everyone to have kind of a uniform development environment, even if they don't all have the same computers. And so what you'll begin to have access to today, and even after the course ends, is an environment that looks like this. It's web-based, this integrated development environment. And if those of you who did take some CS before, it's similar in spirit to Eclipse or NetBeans or Visual Studio or tools like that. But if you're not familiar, you can just think of it as a web application. Site that you're going to have usernames and passwords on that's going to allow you to log in and see essentially an environment like this that has a big window here where you can write code, like we've been seeing on the screen thus far. It's going to have what's called a terminal window at the bottom where, just like we're about to do today, you can type some lower level commands and tell the computer what to do even without using a mouse. And then much like Mac OS and Windows have, you'll be able to see all of your files and folders. This is in the cloud, though, so to speak. And so you have some number of gigabytes in the cloud, and you have only access, or you or your teaching fellow, if you grant him or her access, will have access to this environment. And you can, of course, then access it anywhere on the internet. And frankly, even if you don't have good internet on a vacation or while traveling for school or for sports, you can also download an offline version as well of the same environment. So there's also night mode too, if you're that type. But let's see actually how we use this environment, but really, at the end of the day, how we program. So I have logged in advance already to CS50 IDE. I put myself in night mode here. The address is cs50.io. And you can follow along here if you'd like, but probably better to do this at a slower pace on your own, whether for problem set 1 or later on today. And so let me go ahead and write my very first program. I don't really care about what's going on the left because I have no files and folders yet, except for this folder up here. By default, all of you will have your own workspace folder, and that's where all of your problem sets and files can go. But I'm going to go ahead and hide that by clicking this folder icon, just to kind of simplify what we're looking at. And now there's two parts to the screen. The code editor up here, where you can write code, not that, and then this so-called terminal window down here. So let me go ahead and write my first program. I'm going to go ahead first and do File, Save, just like on a Mac or PC, and I'm going to call this hello.c. By convention, any program you write in this language called C is supposed to end in .c, just like in Scratch, somewhat oddly. It ends in .sb2, if you noticed on your Mac or PC. With C, it's literally just C. And by convention, always use lowercase. And by convention, don't use spaces. Use underscores or hyphens, something like that when making files. Otherwise, it just gets harder to find things in your workspace. So now I have a file or a tab called hello.c, and I can do this pretty quickly because I've done it before, but I'm going to go ahead and type out that program we keep seeing. Quote unquote, hello world, semicolon, and save. Now you'll notice that somehow my code is all very colorful, even though I just kind of typed that out on my Mac's keyboard. You would see the same thing on your PC. That's just because a lot of IDEs, integrated development environments, just color code your source code for you to kind of draw your attention to the functions, to draw your attention to other keywords. It has no meaning, and it's not stored in the file. This is just kind of a graphical user interface feature that you get automatically. But how do I run this program? Like on your Mac or PC, how do you typically run a program? Yeah, you click on it. You probably double-click an icon. On Android or iOS, you just tap an icon. But with programming environments, you can make that possible. And on Macs and PCs, you can absolutely write software as simple as this, save it, and then double-click on an icon. But the reality is, for aspiring computer scientists or data scientists or really just anyone who wants to do more powerful things with computers, you can actually do a lot more with your keyboard, even if you don't type all that quickly. Because nothing we type at the keyboard is going to be all that long or verbose. But you'll find it's just a lot easier and more flexible because you can do more than today's graphical environments do. So this is all to say that if I want to run this program now, I need to actually compile it. Recall that compiling meant taking something that looks like this in code and converting it to that. So I somehow need to run my source code through a compiler in order to get machine code. And there's a few ways to do that. The first way I'm going to do that is as follows. I'm going to click in the blue part of my screen, which henceforth I'm just going to call a terminal window. It's an old school term just describing like a prompt where you can type words and commands. I'll go and zoom in here, and I'm going to do the following. Clang for C language. It's a compiler for the C language. And then I'm going to type literally hello.c. And you might not be in the habit of doing this on Macs and PCs these days, but if you grew up with DOS or with Linux or some operating system, you might have. But now I'm going to hit enter, and nothing seems to happen. And in this programming environment, and the CS50 IDE is running an operating system called Ubuntu Linux, which is sort of different but similar in spirit to Windows and Mac OS, nothing happening apparently is generally a good thing. Because if you don't see an error message, it means the computer has nothing to complain about. So what can I do next? Well, notice the following. If I open up my file browser up here, a couple of things have since appeared. A couple minutes ago, there was nothing except my workspace. It makes sense, probably, that hello.c now exists, because I made that. I went to File, Save. But what do you think a.out is? It seems to be another file, but I did not type this word. Yeah. Oh, say again? Another file? Oh, no. It's what I can execute, exactly. So when I ran the compiler called Clang on my source code, I promised in the slide a moment ago that's going to output machine code, zeros and ones. It would be a little annoying if it literally just spit out zeros and ones on the screen, because that's not useful for me, and the computer doesn't need to see it on the screen. So all those zeros and ones got saved in a file called a.out, just by convention. A is the first letter of the alphabet, and out is output, though the origins are a little fancier than that. But that's all, just the default file name. So how do I run this? Well, on a Mac or PC, I would generally click it, but that's not how I'm going to do this in a command line environment. And that word, command line environment, or CLI is the acronym, I literally have to do everything at the command line by typing commands with my keyboard. And the way I do this is the following. ./a.out. So dot means look in my current directory, wherever I am, like my workspace. Slash is just a separator that you've probably seen on Macs and PCs to separate folder names. A.out is the name of the program. And so now when I hit enter, it's as though I just double-clicked on an icon on a more modern graphical interface like Mac OS or Windows. But I would argue this program's a little bit buggy, right? My screen, beyond just looking sort of new to most people here, it also looks a little stupid at the moment. Why? Aesthetically. Yeah?
It's on the same line as hello world as a workspace.
Yeah, I mean, hello world in white is on the same line as that workspace keyword. And the workspace is just reminding me every line where I am. Because again, it's not graphical right now, it's textual. So I'm literally seeing in blue where I am, what folder I'm in. And frankly, this just kind of bothers me. I'm a little sort of anal, and I don't like how this looks, and arguably it's a bug. But why is that? Well, it's simply because the computer took me literally. In my source code up here, notice I deliberately made this mistake or inconsistency with what we saw a moment ago. I omitted something from this line. What was that? Yeah, the /n, or the \n. So what clearly is that role is that clearly serving? Well, \n is an explicit way of saying, hey, computer, put a new line here. Hit the Enter key here. And it's explicitly written as \n only because doing this, that just feels like messy and kind of non-obvious what's supposed to happen. So programmers years ago decided, you know what? We're going to express the notion of hitting Enter symbolically with \n. That's all. So now, if I go ahead and save the file, which I can do with Command-S or Control-S, or you can be more explicit and go to File Save, just like on your own computer. And now I go ahead and run /a.out, Enter. Damn it. What's wrong? Yeah, I have to recompile. So again, this is a process. I save the file. My source code is now correct, but my machine code is outdated because I haven't recompiled it. Again, the computer is a pretty dumb device at the end of the day. Fast though it may be, it's only going to do what I tell it to do. So down here, I had better do clang hello.c again. Nothing seems to happen, but odds are that changed a.out. So indeed, if I do /a.out, now I see hello world. It puts a seemingly invisible line break on the screen, but now everything looks a little cleaner. All right. But clang hello.c, of course, yields a pretty stupid file name. It would be nice if I could actually name my program hello or hello world or something like that. And we can do this in a couple of ways. So let me go ahead and zoom in down here again. I'm going to clear the screen just to keep things neat. And it turns out I can supply commands like clang, and others will eventually see, with things called command line arguments. I can actually specify, you know what, clang, instead of just taking hello.c as your input, also do this. Output a file name called hello. And this varies by program. Clang is not the only program we're going to see in this blue terminal window. This is now saying, hey, clang, output a file called hello, and take as input that same file as before, hello.c. Why? Well, humans years ago decided O is the first letter of the word output. -O is a nice succinct way of saying output. So -O hello means output a file called hello instead of your default a.out. Again, nothing seems to happen. But if I zoom out, look in my file browser, you'll notice now I have the old a.out and hello in addition to my source code. So just intuitively, how do I go ahead and run this new version called hello? Yeah, it's // because dot means here. Slash just separates here from the file name. Hello, enter, same exact thing. Now, I keep opening the file browser and closing it just so we can kind of see things graphically, but even that's not necessary. It turns out that in a command line environment, you have a whole bunch of commands. For instance, I can type ls, which is a succinct way of saying list. Hey, computer, list all of the files in the current folder. The current folder is called workspace. That's why I keep getting reminded of it in blue. And now you'll see three things, a.out with a star, hello with a star, and hello.c, and they're also color-coded. It turns out that in most text environments, if you configure them this way, any program is highlighted in green, and it has a little star next to it, which means it's executable. You can run it, not by double-clicking, but by doing /program name. Anything in white here is just a text file, like hello.c. I only have one of those. And it turns out if I had folders, I would actually see their names as well. And I can create folders, just like in Mac OS and Windows, in a couple of different ways. I can actually go with my mouse up to my file browser up here. I can control-click or right-click on there. And I can scroll down to the bottom and say new folder. And when I do that and zoom out, you'll see new folder. And maybe I want to do this for pset1, problem set 1, and hit enter. And now I have a folder called pset1. I can see this in my command line environment by typing ls again, enter. And now notice I have those same two executable programs, that same text file, hello.c, and now a directory in blue called pset1. And the trailing slash just indicates, hey, human, I am a folder. So how can I open pset1? Well, in Mac OS and Windows, you would, of course, just like double click and things would expand and show you what's inside. But this is, again, a textual environment. So let's put that away, go down here, and change into pset1 as follows. cd is another command in a Linux environment. And again, Linux is just another operating system like Mac OS or Windows that we are running in the cloud for you. And if I do cd pset1 with or without the slash, doesn't matter, and hit enter, my prompt just changed. And my prompt is just literally the words on the screen, just reminding me where I am. In blue, it previously said workspace. Now it says workspace/pset1 because I have done the equivalent with my keyboard of double-clicking on pset1 and opening it up and going into it. So just a guess now, if I type ls inside of my pset1 directory and hit enter, what should I see? Hopefully nothing, because it would be a little weird if all I did was create a folder and suddenly there's stuff in it, and indeed, there's nothing in it. Hitting ls and then enter just shows me nothing, which means nothing is in it. Meanwhile, if I decide, this was a mistake, I'm getting ahead of myself, I can go back. And this might be a little non-obvious, but cd space ... means go back one directory, or technically go into your parent. You can actually think of your Mac or PC's folder structure and the IDEs as this tree, like a family tree. And I just went down into the child of workspace called pset1. So cd ... takes you back, if you prefer that mindset, or takes you up, if you prefer the family tree mental model. If I hit enter now, my prompt changes back to workspace. If I type ls, I'm comfortable again. I see the things I know. And if I want to remove that directory, I can just type rmdir for remove directory, pset1, and it's gone. And I can confirm as much with ls. So in short, this is the textual way of doing things that you've probably been doing for years on your own Mac or PC or even phone these days. Whew. OK. So none of that is sort of intellectually interesting. Like, we learned how to make files and folders. Let's now actually dive in deeper to some of the code and the ideas with which we actually solve problems. This first program didn't do all that much, but it did kind of express an idea. And we're going to start to take for granted even more so what a function actually is. And maybe just to make this point clear, let me go ahead and do this. Let me change the screen to just a blank canvas. That's all the circles I was drawing earlier. Can we get one volunteer, maybe exchange for a stress ball? OK, right, very quickly. Come on up. What is your name?
Sam.
Sam. All right, so Sam, we have a name tag here for you. But instead of calling you Sam, we're going to call you, for the moment, printf. So if you don't mind, hello, my name is printf. OK, thank you. Put that wherever. All right, so now I am, for the moment, you can stay there for just a moment. I, for the moment, am the programmer on my computer here. And my goal is to simply print out onto the screen, hello world. Now, I've been programming for years. I have different monitors over the course of the years. And I don't really care how the words I type in my program actually get on the screen. I kind of want to delegate that functionality to someone or something else. And thankfully, Sam has been programming for some time. He knows how to talk to computer screens or print things out on the screen. And so I can literally kind of outsource functionality that I want to use, but I don't want to care about how it is implemented or how Sam implemented it by just kind of calling Sam over and asking him to do something. So in this case, if Sam, you are now actually printf, I'm going to go ahead on a piece of paper, and I'm just going to tell you, if you don't mind, by passing you input, I'm going to hand Sam a slip of paper that literally says hello world. And if you don't mind, could you go print this on the screen, since you are indeed printf, and you can do so just with your finger on the screen. So here I am, the computer program. I have no idea how printf is working. I just know that I wrote a line of code. I ran the program. Printf is in motion. It's doing its thing. And perfect. Oh, and then Sam, come back to me. And now Sam is done executing, if you would. Thank you very much. And that was a ridiculously belabored way of making the point that functions aren't intellectually like all that interesting. It really is just this packaging up of functionality that I don't necessarily need to know or care how it works, but I want to get the job done. And in fact, we can do one more job, if you don't mind changing your name for just a moment. How about in exchange for 2 stress balls? So now I'm actually going to call you, or rename you, getString. Because it turns out that in the computing world, technically, it doesn't add all that much to put this on, but that's OK. So in the computing world, there's a whole bunch of other functionality that you can use, some of which is CS50 specific, but most of which is not. And so in fact, if I go ahead and open up here this list, some of the functions we're about to start using and taking for granted are these. GetChar for get me a character. GetInt for get me an integer. GetString for get me a string or a sentence. GetFloat for something even different. And still, I don't know how those work. I don't really know how keyboards work or where the input comes from. But thankfully, someone else did. Sam, in this case, he implemented getString. And so now, if you wouldn't mind, Sam, I'm going to write another program with you right there. And it's going to look instead like this. I'm going to go ahead and create a new file called get_string, or rather string.c. I'm going to go ahead and do include standard.io.h. int main void, which is just copy and paste from before. But instead of just typing out hello world, I'm going to do this. String s gets get underscore string name. And then I'm going to do printf, quote unquote, hello, comma, %s, \n, s, semicolon. Now, what is going on? We'll come back to line 6 in a moment, but line 5 is now doing two things. On the left-hand side, it's declaring a variable called s that's going to store apparently what type of data? A string, which is like a word or sentence, paragraph, or whatever. It's characters from the keyboard. And what's going to go inside of s? When we talked about variables earlier, we put inside of another variable called I, the number 0. Here on the right-hand side of the equal sign, we're instead putting the name of a function, which is kind of interesting because before, when Sam was a function called printf, he just did something and he came back to me, but he didn't hand me anything. I just sort of thanked him and moved on. But in this case, I actually want Sam to, if you would, just go into the audience for a moment with this pen and piece of paper and just go literally get me a string. Get me the name of someone if you could.